Bienvenidos, Ushamadid, and welcome UMGC learners from the CMIT-455 Section 6380 CCNP ENCOR version 8 Cisco Networking Academy course for the spring 2021 semester. In this tutorial, we're going to be taking a deep dive look at Packet Tracer Activity 5.2.1, and we're going to be expanding from this activity into our conversation about the VLAN Trunking Protocol and the Dynamic Trunking Protocol, or VTP and DTP respectively. Now, it's very important to remember right out of the gate that VTP and DTP are both Cisco proprietary protocols. In fact, we're going to take a look at the copyright trademark filing for DTP, which Cisco submitted quite some time ago. But let's dive in right now and take a look at the activity that we're going to be working with. I already have the switch consoles and terminal windows opened up, but here is the activity that we're going to be working with today. As you can see, we have the addressing table with a bunch of information up here, and we're going to start by configuring DTP. Now, the reason that we're going to start with DTP is very, very important. If I simply take two Cisco switches, and I'm referring, when I say Cisco switches, we're talking in the context of newer Cisco Catalyst switches, like the 3650s, or the 3850s, or the 9300s, or the 9200s. Those are the switches I'm referring to when I'm saying Cisco switches. Now, there are older Cisco switches, such as the 3550, which of course are end of life, end of sale, end of support, and should not be used in your environment. But in a lab environment, you may run into those switches. And here's why I bring that up. On the newer Cisco switches, when you plug two switches together, so we'll say here's switch 1, and we're just going to simply say that we took these switches out of a box and ran an Ethernet cable between the two ports here. And we'll just say that this is gig 01 and gig 01. Now, this is where learners will first become confused, because the expectation for many learners is that if I take two Cisco switches out of the box, and again, I'm saying newer Cisco switches, and I plug those switches together, I have just created a trunk link. And we'll just put a T here. Now, that would be a misunderstanding, and that would be incorrect. When you take two Cisco switches out of the box and you plug these switches together, DTP, or the Dynamic Trunking Protocol, is working. It's on by default, but it's the default mode on newer Cisco switches that is going to drive what happens here as to whether this is a trunk link, or is it a trunk link, or do they negotiate to be access ports? So are they going to negotiate to be trunk ports, and is it going to be a trunk link, or are they going to negotiate to be access ports, and are we just expanding the broadcast domain? And we'll simply say we're working with VLAN 1 here between these two switches. On newer Cisco switches, the Dynamic Trunking Protocol mode by default is Dynamic Auto on both sides. Again, we're saying by default, out of the box, we take them out, we plug them together. Now, the reason that the mode is Dynamic Auto is with older Cisco switches, specifically the 3550 mode, which I'll talk about. Those used to have Dynamic Desirable as the mode, the default DTP mode on either side. The problem with that is that when you plug those two switches together, they automagically form a trunk link. And if that's the case, both ports would become trunk ports and a trunk link would be formed, you can run into security issues with VTP. And so numerous customers express their concern to Cisco, and on newer Cisco switches, and again, this would be anything that you're buying from Cisco today, the default DTP mode is going to be Dynamic Auto. And if both sides are auto, a trunk link will not form. In fact, what will happen is it will simply be an access port. That is sort of the fail-safe, the fallback mode when both sides are dynamic auto. And this is extremely important because all we've done here by connecting these two switches together, saying that everything is in VLAN 1, is we've simply extended VLAN 1. Because that is going to be a VLAN 1 access port, and this is going to be a VLAN 1 access port. And that is what would happen out of the box by default. So we've expanded the broadcast domain, and that's really all we've done here. We haven't enabled this link, and I'll get rid of the T here, it's not a trunk. We have not enabled this link to carry VLAN traffic for more than one VLAN. Right now, the only VLAN that is allowed to transit this link is VLAN 1. And we're saying that all of our ports are in VLAN 1 as well. So remember that, because that is one of the big misconceptions when learners see links between switches. They immediately think, oh, those are trunk links, when in fact, by default, they are not. And that is why we're starting with DTP. The other reason this activity begins with a discussion of DTP, the Dynamic Trunking Protocol, is that VTP, the VLAN Trunking Protocol, will only work across trunk links. So what am I saying there? I'm saying that if you took two switches out of the box and you plug those switches together, and both sides are dynamic auto by default, it's going to negotiate and fall back to being an access port between those two switches. Meaning, if I turn the VLAN Trunking Protocol on those switches, it will not function because it has to be a trunk link between the switches in order to work. And again, we're going to go into a more complex scenario here as we make our way through. I'm going to take you into the Cisco Modeling Labs, and we're going to look at the diagram 5 in the text, from the text, which is figure 5.1, where we have 6 switches we're going to be looking at. And we're going to take a look at that a little more in depth to see what exactly happens. So here is the first thing that we need to do. We need to configure and verify DTP because we need trunk links for VTP to work. So here's what we're going to be doing. Step 1, verify the VLAN configuration. So we're going to click on switch 1. We're already there, and I pulled this up to save us some time from kicking these windows open. Again, we're in user exec mode, as indicated by that greater than sign. The enable command puts me into privilege exec mode. Because if I say disable, right, and this is important. If I say disable, it puts me back in user exec. When you say enable, it puts you in privilege exec. A lot of users will say exit. That will log you off your session, and you got to come back in and you're in user exec. So if you're in enable mode, which is privilege exec mode, and you want to go back to user exec, say disable. So we'll go enable to get into privilege exec mode, because if I said disable and I say show VLAN brief, let's see what we see here. Well, we still see the same output that we would see even if we were in privilege exec mode. Again, I just want to show you the differences between the modes and what you will see and what you won't see. If I say disable and I say show run, you'll notice that command is not available to me. I need to be in privilege exec mode in order to see the running config. All right, so let's say show VLAN brief. And here you can clearly see that all of the ports, including the gig ports. And remember what I told you in the previous video. If a port is a trunk port, does it show up in the output of show VLAN brief? Or in show VLAN for that matter? And the answer is no. And so we can see here that it looks like we don't have any trunk ports. How could we tell show interface trunk? And we don't have any output here, meaning there are no trunk ports currently configured. So if that's the case, and they've nicely, I like how they've labeled the ports here so that I don't have to click into the activity, hover over the link to see what the two ports are. So if gig 01 and 02 show up in the output of a show VLAN brief, and I were to ask you how many trunk ports, or let me rephrase that, are gig 01 and gig 02 trunk ports? And if you see them in the output right here, and more importantly, take a look at this. They're listed here in VLAN 1 along with everything else. So that should be a dead giveaway that these are not trunk ports. How else could we check that? Instead of saying show interface trunk and saying, so we've seen two different ways so far to tell whether that link is a trunk link. Show VLAN brief. If it shows up, those ports, gig 01 and 02, they are not trunk ports. If I say show interface trunk and I don't see anything, I don't have any trunk ports. And now here's a third way to check. What if I say show interface, gigabit Ethernet 01, switch port? Now, this show interface switch port command, this is a great command to keep in your networking toolbox. So there's the output of just that one port. If I was to say show interfaces switch port, it'll show you all the ports, right? So you're going to get to see a whole bunch of stuff there. We're just interested in this one port. And in fact, let me go ahead and we can chew up a little bit more space here so we get it all in one window. So here's the output of that command. You can see that the switch port is enabled. Now, here is where you can see what the default administrative mode on this specific port for DTP is. So the dynamic trunking protocol default mode here is dynamic auto. What is the operational mode? So in other words, that's the default mode or the mode to which this port has been set from a DTP perspective. Oops, sorry, I just actually hit notepad and a pen there. The operational mode. This is the mode to which, after DTP negotiated, this is the mode to which the port has moved. Static access. And so we can see the trunking encapsulation is going to be .1Q. The operational trunking encapsulation is native. And the negotiation of trunking is on. This is also important. Remember that command switch port no negotiate. If we were to say switch port no negotiate, we would be turning off that port's participation in listening to and negotiating the trunking mode. So you can see it's static access. And so let's say show run. And let's take a look here. And you can see that it doesn't have switch port mode access configured on the port. It doesn't have to because it has negotiated to a static access port. And that's what we're seeing. Because the mode is dynamic auto and both sides are dynamic auto by default on newer Cisco switches, it will negotiate to an access port. And that's what's happening here. If one side was dynamic auto and the other side was dynamic desirable, we'd get a trunk port. If one side was hard-coded to on, meaning switch port mode trunk, and the other side was either dynamic auto or dynamic desirable, we would get a trunk port. So the only time you don't get a trunk port is when two switches are connected together and the default DTP mode on that port has been set to dynamic auto. And what do we get in that case? We get an access port. So right now, all we have is one huge broadcast domain for VLAN 1, right? And right now, VLAN 1 is the only VLAN that is configured between all of these. I should say that these access ports are connected up to, because we saw that from the show VLAN brief, right? We say show VLAN brief, and what VLAN are all of the ports configured in right now? VLAN 1. And so that goes back to the scenario that I presented earlier. All right, so we've got one big massive broadcast domain here for VLAN 1. Let's take another look here. We'll go from user exec to privilege exec, show interface trunk. Any trunk ports? No trunk ports, right? And what about show VLAN brief? All right, again, everybody in VLAN 1, and everybody means all of the ports are in VLAN 1. We'll take a look at switch 3. We'll jump onto the CLI. We'll go from user exec to privilege exec, show interface trunk, no trunk ports, show VLAN brief. And again, this shows me that gig 01 and 02, which are what we're using here, are not trunk ports. If they were, they would not show up in the show VLAN brief output. All right, so we took a look at that. It says what VLANs are configured. Well, VLAN 1, your default VLAN. It's there. Can't be deleted, right? VLAN 99 is our management VLAN. And then we've got this sort of innocuous mysterious, let's say, VLAN 999, which has no name. We don't really know what's going to happen with that, but we will here shortly. So now we're going to configure trunks on switch 1, 2, and 3, because again, for VTP, the VLAN Trunking Protocol, to work, you have to have trunk links between the two switches, or the switches you have to have trunk ports between them that are operational in order for VTP to send its messages and for VTP to properly function. Remember, VTP is all about allowing you to scale out the size of your layer 2 domain. Because if we only had a single switch, then enabling VTP really doesn't buy me anything, right? Because I'm going to go onto that switch and I'm going to configure that switch and I'm going to configure the VLANs on that individual switch, no big deal. But what if I have 5 switches or 20 switches and they're all connected together? Then the use case, remember, I talked about that yesterday in the video I recorded. The use case drives all of your decisions. So you've got to think about, what is the use case? What am I trying to accomplish? What's the environment going to look like? And it also helps to begin with the end in mind. What is the end state going to ultimately be? And then there's your use case. So again, VTP is proprietary, DTP is proprietary. And so think about that when you're making those decisions. So what we're going to do here is on switch 1, they want us to go ahead and say in global config mode here, interface gigabit Ethernet 01. And we're going to say switch port mode, dynamic, desirable. Now, as soon as I do this, the port on the other side, so if this is gig 01 and I'm on switch 1, switch 2's gig 01 is set to dynamic auto. And take a look at what you see immediately. The state changed. It went up, down, up, right? So it transitioned, the line protocol transition there. And VLAN 99 is all of a sudden up. Because before this, VLAN 99 was active, but the interface for VLAN 99, so I say do show IP interface brief, the VLAN 99 interface was not up. Okay, it would have been, and in fact, if we were to take a look on switch 3 over here, let's say show IP interface brief, VLAN 99 is up, down. Remember, it's up because the VLAN has been configured. We said VLAN 99, name, management. I think the name is management. So we said VLAN 99, name, management. That would go ahead and bring that up. However, it's down because of the auto state feature, which means we don't have any ports, either access or trunk, on VLAN 3, on switch 3, that are configured to allow VLAN 99 on that port. And remember, by default, trunk ports will allow all VLANs to cross the trunk port. And so that's why it's up, down right now. Over here, it's up because we've brought the trunk link negotiated with the DTP packets, which DTP by default, you've got every 30 seconds, there's an advertisement that's going to take place with those DTP packets. So now, what if I say do show interface trunk? Well, lo and behold, we have a trunk link. The N, what do you think that means right there? With the encapsulation, because prior to this, we only saw 802.1q here. Now we're seeing N-802.1q. Exactly, it means it negotiated. And so the mode is not auto, the mode is not on, the mode is desirable from the command that we just ran, which was switchport mode dynamic desirable on that gig 01 port. And so what happened is we changed this to dynamic desirable. This side is auto. And so DTP will successfully negotiate and bring up a trunk link. And that is what the N stands for, that the trunk link was negotiated using the dynamic trunking protocol. So now let's take a look. Let's circle back onto switch 1 and let's say do show interface gigabit Ethernet 01 switch port. Whoops, and we don't have any context sensitive help there. I hit tab and it doesn't help me because we are in interface sub-configuration mode. So you're going to have to type it all out. So you can see the port is enabled. What about the administrative mode? Well, remember, we changed the administrative mode to dynamic desirable. The operational mode is no longer static access, it is trunk because it has negotiated to a trunk. The encapsulation is .1Q. Now it says it's negotiated to .1Q, and I think that's interesting. It'll be interesting to see if on newer switches, and again, it negotiated, we see this in it negotiated, but on newer Cisco switches, it will always negotiate to 802.1Q by default because that is the only trunking protocol or encapsulation mode that's in use is 802.1Q. ISL, which is inter-switch link, which was another Cisco proprietary invention, and the story for that goes way back to spanning tree and Cisco's desire to do per VLAN spanning tree. And so ISL is no longer used. It's not even an option on newer Cisco switches. In fact, let's take a step over here. This is a good segue. Here's our activity. Or here is the figure 5.1, the diagram in the text, and I've recreated it here because we're going to have a larger conversation, and this is Cisco Modeling Labs. And so this is as close as you are going to get to the exact iOS software, right? And you can see here real briefly, also let me segue for a second. You can see that we've got all kinds of things going on here. We can do CSR 1000Vs. We can do desktops, which are Ubuntu desktop, or Alpine Linux desktop, sorry. You've got iOS routers, iOS layer 2 switches, NXOS, iOS XRVs. So you can buy this, right? And you run a virtual machine, which is what I'm doing. And then this is the interface to that virtual machine. And I'm using VMware Fusion for the Mac, because this is a Mac that we're on here. So, but again, this is Cisco Modeling Labs, and this is the high-end, closest thing you're going to get to real Cisco iOS, and it is an amazing tool, as you'll see. So let's go from user exec into privilege exec. I'm on switch 1. And what we were talking about was the fact that if we looked at this packet tracer activity one more time, you can see that 802.1Q is the encapsulation mode. So here, if I say show interface trunk, you can see that we don't have any trunk links configured. Let's say show IP interface brief. And we can see that we've got 4 interfaces on switch 1. If I was to go into interface gigabit 03, I'm sorry, let's go into global config here, and then go into int gig 03, and then say do show interface gigabit Ethernet 03 switch port. You'll see that we see much the same thing with respect to the output. And let's make that a little bit bigger there so we can get everything on one screen. We've got the name, the switch port's enabled. And take a look at that. The mode is dynamic auto, right? The administrative trunking encapsulation is to negotiate. The operational trunking encapsulation is native. Negotiation of trunking is on. Again, DTP is functional on this port. Now, if I'm on this port and I were to say switch port mode trunk, right? You can see that an interface whose trunk encapsulation is auto cannot be configured to trunk mode. So what that's saying is that the mode of this interface is right now it's dynamic auto. I simply can't say switch port mode trunk. But what if I say switch port encapsulation? You'll notice, you see, there is no command here for switch port encapsulation to change the encapsulation. So I can't even change the encapsulation from .1Q because that is the only mode supported on newer Cisco switches. All right, so let's step back to our activity here. And you can see we said switch port mode dynamic desirable. Let's go ahead on interface gigabit Ethernet 02, interface gigabit Ethernet 02, and instead of allowing DTP to function and saying switch port mode dynamic desirable, we're going to say switch port mode trunk. And we're going to see that the mode will be on because we have hard-coded that port on switch 1 to be a trunk port. So do show interface trunk. And you can see here the mode is on. There was no negotiation. We don't see the N for negotiation. What we see is it's 802.1q because that is the only encapsulation mode supported on trunk links, right, is 802.1q. And so we're set there. So we've said switch port mode trunk there, and you'll notice it says the status is trunking, the native VLAN is 1. But what about over here on switch 3? Well, take a look. The interface for VLAN 99 changed to up because we are saying here that I want you to be a switch port no matter what. That was that switch port mode trunk. So let's come back over here. We're going to go into global config and we're going to say interface gigabit Ethernet 02 and I'm going to say switch port mode trunk. And so now this is also a trunk link, right? So are they listening for DTP packets still? How could we tell that? So let me save the config here and say show interface trunk. And you'll see there's no negotiation. It's 802.1q is our encapsulation. And that's that VLAN tag that's put on all the packets or the frames that are crossing that trunk link. And the mode is on, right? And that means we said switch port mode trunk. But what if I say show interface, what is it, gigabit Ethernet 02 switch port? And we come up and we see up here the administrative mode is trunk, right? Because we've hard-coded it. And it came up as the operational mode. So we hard-coded it as a trunk link. What is it actually functioning as? The operational mode is as a trunk. The administrative trunking encapsulation is both .1q. And you can see negotiation of trunking is on. So DTP, just because we say switch port mode trunk, does not mean that we have disabled DTP, right? Now, it is a Cisco best practice, and I'm going to say something that you should probably be saying to yourself, wait a second, why is DTP on by default then? Because this is what I'm going to get ready to tell you. The Cisco best practice is, if you know those are going to be trunk links, and you want them to be trunk links, you hard code them as trunk links with switch port mode trunk, and you disable DTP. So you disable the port from listening for DTP advertisements by going into the port gigabit Ethernet 02 and saying switch port no negotiate. That is the command that will ensure that that port is no longer participating with DTP, the dynamic trunking protocol. So we say show interface gigabit Ethernet 02 switch port, and now what does negotiation of trunking say? Off. It is no longer on. It is off. But we don't need it to be on because we don't want it to try to negotiate. We know it's going to be a trunk port, so we hard code it as such and turn DTP off. So you might be asking, well, why would Cisco leave all that stuff on by default if they're just going to turn around and tell you that the best practice is to turn it off? And there's a very easy and simple answer for this, is that Cisco, out of the box, wants you to be able to plug and play. It wants you to be able to plug things together and to have things function for you, right? And so that's why in a lot of cases, you'll see that a lot of these things are on. But they will then tell you when you get into the configuration of that hardware to go ahead and turn certain features off that are no longer needed. Because logically, if you think about it, if I'm saying switch port mode trunk, and I know that it's going to be a trunk link, why would I want to have negotiation on? Because I'm a decent network engineer and I don't need to have it negotiating. And again, I could be opening myself up to issues where I might have something come up and negotiate to a trunk link, and I don't want that, right? So I hard code it as a trunk, and that's what we go with. So we've done that on both switches. The native VLAN is 1, as we've seen. So configure VLAN 999 as the native VLAN for the trunk links on switch 1. So we're going to come to switch 1, and here's where we're going to see an inconsistency pop up. So int gigabit Ethernet 01, switch port trunk native VLAN 999. So now we know why the VLAN 999 exists. They didn't give it a name, but now we know why it exists. And here is what's going to happen. You're receiving a spanning tree per VLAN ID error. The BPDUs, those bridge protocol data units, that spanning tree exchanges between switches are now inconsistent. You can see the peer VLAN ID is 1 on Ethernet, on Gigabit Ethernet 01. Ours is VLAN 999. And so we know that it's 1 on switch 2 and 3 because we saw that in our earlier do show interface trunk work. So now I'm going to say do show interface trunk, and you can see that it shows the output. We've got this inconsistent VLAN because we've got 999 configured here, but it's set to 1 on gig 02, and on the other switches, it's set to 1. So let's go ahead and you can also see this is what's going to happen. We're now going to start receiving syslog warning messages, right? Severity 4, that we have a native VLAN mismatch that's been discovered. You can see gig 01, we have 999. Switch 2 has VLAN 1. And so that's a problem. The native VLAN must match on both sides of the trunk link. So let's go into gig 02 and let's do the same thing. And let's say switch port trunk native VLAN 999. And that's what the activity was asking us to do. And it asks us about the messages that we're receiving and how we could correct it. Well, the easy way to correct it is they kind of tell you right here is we need to configure, we need to have a matching native VLAN on both sides. So let's come over to switch 2, and we're going to get rid of this inconsistent error and these syslog messages that we're seeing. We'll go into privilege exec, into global config, into int gig 01, and switch port trunk native VLAN 999. And for that link, that is going to clear up the inconsistency that we had. And let's do the same thing over here. And we'll go into global config, interface, gigabit. Oh, wait, did I do gig 02 over here? Okay, I did the right one, just checking. All right, so we'll say interface gigabit Ethernet 02, native VLAN mission. You can see we've got the, you get that output coming to the console, which is now disrupting what we're trying to do. So switch port trunk VLAN, native, I always want to say VLAN first, native VLAN 999. All right, so there we go. Now the port consistency from a spanning tree perspective has been restored because now the native VLANs match on both ends. So what do we have? It says verify that trunking is successfully configured on the switches. You should be able to ping from one switch to the other switch using the IP address configured on the SVI. It's that virtual layer 3 interface, the switch virtual interface, that allows me to manage, helps me manage the switch from a layer 3 perspective, right? So let's come back up here and we'll take a look. So I'm on switch 3, so let's just give it a try here. And let's say ping over to 192.168.99.1. So can I ping switch 1? And we may lose that first couple packets as an ARP request goes out and they time out. Can I ping 2? And so we'll see if we can ping over to switch 2. And again, this traffic is going across those trunk links, and this is control plane traffic. Excuse me, because it's being generated by the switches, right? Or in this case, by switch 3. So if I can ping switch 1 and I can ping switch 2, we've got connectivity and we know those trunk links are up. If we had native VLAN mismatches on those trunk links, we would not have connectivity. So now we're going to configure VTP. And here's where the conversation is going to get a little more detailed. Again, DTP, the Dynamic Trunking Protocol, is kind of short and sweet. Dynamic auto, dynamic desirable, on. We know that if it's going to be a trunk link, we're going to set it to switch port mode trunk, and we're going to turn DTP off. Because if I hard code it as a trunk, I don't need it to negotiate to be a trunk. So we say switch port, no negotiate. And if it's going to be a trunk link, Cisco best practices is switch port mode trunk, switch port no negotiate. So now that we have trunk ports, we can use the VLAN Trunking Protocol, VTP. So switch 1 is going to be the VTP server, switch 2 is going to be a client. all the switches will be configured to be in the VTP domain CCNA and use the VTP password Cisco. And I'm going to talk about that as well, because you're going to see that with VTP version 1 and VTP version 2, remember, VTP version 1 is your default version. But both version 1 and version 2 of VTP, the VLAN Trunking Protocol, have serious deficiencies when it comes to not only the password, but the number of VLANs and the scale that they can go to in terms of the number of VLANs. And we'll talk about that here in just one second. So VLANs can be created on the VTP server and distributed to other switches who are either servers or clients and have them installed, right? And so that is very important. There's going to be 4, I'll call them modes, or you can think of it as roles, but there's 4 modes, 4 roles, I should say, that we're going to be working with. I'm going to use roles because it's actually, they're the 4 roles. You'll hear some people say, oh, what mode is it? Because the mode command is where you say VTP mode client, VTP mode server. But we'll talk about it in terms of the roles that the switches are going to play. And those roles are either server, client, transparent, or off. And we'll see here very quickly whether or not the off mode shows up, because at a CCNP level, you need to be aware of that fact. So let's get out to global config mode here, right, on switch 1, and they want me to say VTP mode. Now, here's the thing. The VTP mode by default is the server mode. Now, you'll notice here it says setting device to VTP server mode, right? But what if I say do show VTP status? Okay, well, this one was set to transparent mode. By default, you should see server mode. How can we check that? Well, let's come out over here. Whoops, I'll make that a little bigger. Let's jump on to switch 3 here. Let's take a look at the console on switch 3, and let's say show VTP status. And you should see that the mode is set to server mode right down here. So you see VTP operating mode server. And did I not look at the right? Okay, yeah, it did come back and say VTP operating mode is transparent. So by default, you will see server mode. And again, Packet Tracer is an amazing tool, but there are some things that require a little further explanation when we start looking at the output that we're getting here. So it could be that someone came in and set this to transparent mode. And typically, individual switches in smaller environments are set to transparent mode, because you can see here we had some VLANs that had already existed, that had already been configured, right? You can see that we're running VTP version 2. So someone came onto this switch, and again, this is not unexpected in a smaller environment. I was anticipating that no work had been done on this switch yet. So you can see here it's set to transparent mode, meaning that while it will pass on VTP advertisements, VTP messages, it is not installing any of the VLANs. It's not going to be using any of the VTP information. It's transparent. It's basically saying, hey, I'll go ahead and pass your VTP messages along, but I'm not interested in being part of your VTP domain. Not interested. And that's transparent mode. And that is typically in a small environment, you will see all of the switches set to transparent mode, and then people would, the network engineer would just go onto those switches and make the individual VLAN changes on each of the switches instead of using VTP. All right, so we are set to transparent mode. So let's say VTP mode server, and now we've changed our mode over to server. We're going to set the VTP domain. And this is important because if you don't set the VTP domain, right, you'd be using the null domain. And that's what you see here. There's nothing here, but it's not that it's nothing, it's null, capital N-U-L-L. So it is set to something, it's set to null. It just doesn't show up there as being configured. So let's say VTP domain, capital CCNA. And basically proving my point, it tells me changing VTP domain from null to CCNA. And then we're going to set the VTP password to all lowercase Cisco. Now I want to show you something right now. Someone gets onto your switch and says, do show VTP password. they're going to see that password in plain text. And you might be thinking, well, what if you put service password encryption on there? That would encrypt it, right? No, it doesn't. So this is one of the deficiencies with VTP version 1 and VTP version 2, is that when you set the password, again, Cisco's been very clear on this in a number of cases. These passwords for VTP, like for VTP and other areas where you would use a password, it's not supposed to be an AES 256 encrypted, unbreakable password. That's not the purpose of the password. The purpose of the VTP password is not to keep someone out of your switch. Again, remember, if I was to say exit and then disable and say show VTP password, you'll notice that from user exec mode, I can't get there, right? But if I go into privilege exec mode and say show VTP password, I can see that. But here's what Cisco's saying. We're putting the password, we're allowing you to configure the password for VTP to prevent another switch from mistakenly joining your VTP domain. That's the purpose of this VTP password. The purpose of that password is not to hide the password from you or to make it impossible to see, because remember, if I'm in privilege exec mode here, and let's say that I'm a bad actor, you have bigger problems right now than me knowing your VTP password, right? Because it's from here I can go into global config mode and do a write erase and then save the config and then reload your route or your switch or your router or whatever, right? So it's, again, Cisco has been clear on this, and there's a document, I'm not going to look it up right now, but there's a document out there where they talk about using these simple passwords that are not sort of hashed or encrypted in any form or fashion, because the purpose of the password isn't to prevent a bad actor from doing something malicious. Again, to see it, I'd have to be in privilege exec mode anyway. And so the least of your concerns at that point is that, oh, he knows the VTP password. No, the bigger issue is, well, he knows the enable password, right? That's the problem. So it's not meant to be this, unbreakable type thing. And you'll see that VTP version 3, which I'm going to do some examples with, you'll see that when we're talking about VTP version 3, we can hide, in other words, hash that password so that it's not easy to see. All right, so VTP mode server, domain CCNA, password Cisco. So now let's say show VTP status and see what we see. Do show VTP status. And here it is. We're running VTP version 2. The configuration revision is 0, meaning I haven't created, deleted, changed any VLAN information. We can support 255 maximum number of VLANs. Number of existing VLANs is 7. So let's talk about that. Do show VLAN brief. Why is it 7? Well, it's VLAN 1, 99, 999, 1002 to 1005. So 1, 2, 3, 4, 5, 6, 7. And so it's taking into account all of those VLANs. And this is the next limitation with VTP version 1 and 2. They only support the regular standard range of VLANs. And I'll say 1 to 1005, but let me be clear, right? VLAN 1, we're not using, okay? So it's VLANs 2 to 1001 that we're working with VTP, because VLAN 1 is already configured. We can't configure VLAN 1, and we shouldn't be using it anyway. And VLANs 1002 to 1005, those are reserved for, as you can see, FDDI, token ring, and it'll be interesting to see at some point if those go away, because FDDI and token ring, certainly not popular technologies today in the networking space. And so we're kind of limited there really to VLANs 2 to 1001, right? That's the range that VTP version 1 and 2 support, is your standard range of VLANs. VTP version 3 supports all of them. I'll say from 1 to 4094, but keep in mind that VLAN 1 and then 1002 to 1005, we're not talking about those, right? Because those are there. Those are always going to be there on your switches. So VTP version 3, fixes that limitation. All right. And there's your use case conversation for you as well. Okay, hey, how many VLANs are we going to be using? Well, we're going to be using 2. Well, do you need VTP? Then you might have to think about, well, how many switches do we have? We've got like 3. Well, all right, I can survive. I'll put them in transparent mode, put the switches in transparent mode, and then configure everything locally, right? How many VLANs are we going to use? There's going to be about 2,000 VLANs in use. We've got 15 switches that are involved. Okay, pump the brakes right there. That is a use case where maybe VTP is the solution that we're going to need, and VTP version 3 is going to be mandatory if that's what you're going to do to support 2,000 VLANs. Because VTP versions 1 and 2 do not support all of the VLAN ranges that we're talking about here. And again, and to be clear, right, it's going to support, I'm talking about, when I say the VLANs, we're talking about the VLAN numbering scheme that you would use. It's going to support a maximum of 255 VLANs. If we go back to the output here, you can see that, and that's packet tracer. You can see here, it says 1005. On a real Cisco switch, it's going to say, it's going to support all the VLANs. And if I was to change the mode on this switch to VTP mode, or I'm sorry, VTP version 3, and this is going to be good because we're going to get an error here, right? And I've seen this happen before in Learner Labs where it says, oh, the domain name isn't configured. And I've seen learners do this, IP domain name ccna.com. And then they rerun this command and it doesn't make sense. The domain name that it's referring to there is not the domain name configured on the switch. It's the VTP, the VLAN Trunking Protocol domain name. So VTP domain, and I'll just say CCNA. And so you can see it's changed it from null to CCNA. So now if I say VTP version 3, you can see that it's going to switch to version 3. So do show VTP status, and let's see how many VLANs are supported. So 4096. So again, just an important note that what you're seeing here is not reality, right? It's Packet Tracer is a great software tool, but there are some limitations to it. So know that when I say VTP versions 1 and 2 will support all standard range VLANs, that is correct. But we're not talking about VLAN 1 and 1002 to 1005 because those are already in use and we're not configuring those, right? But when we say VTP version 3 supports all 4096, I think is what it showed, 4096, it's certainly not VLAN 0, that's reserved. It's not VLAN 4095, that's reserved. And we're not talking about 1002 to 1005, those are reserved. And VLAN 1, again, already configured, it's the default, we're not using that. So I just wanted to segue there to make sure you see how it would really look if we were tweaking the VTP modes. All right, so to verify the VTP password, say show VTP password. Now we're going to add switch 2. Let's make sure we did everything correctly here, and we saw that. All right, so switch 2 and 3 are now going to be added to the VTP domain. So we come over to switch 2, and we go from user exec to privilege exec into global config. We're going to say VTP mode client, meaning we can't change VLAN information on switch 2, but it will receive the VTP advertisements and update its VLAN database from switch 1, who is a VTP server. VTP domain, CCNA, all caps, VTP password, Cisco, all lowercase. And then let's go ahead and say, do show VTP password. And again, you can see it, do show VTP status. And there we go. And take a look. The revision number is still 0. Nothing has changed. We are a VTP client. Okay. And so now it wants us to do the same thing. Okay, so actually switch 3, and this is going to be good the way that they're doing this. Switch 3 is saying that it's going to be a transparent mode switch. So let's say do show VTP status. So has anybody changed this to transparent mode? Well, it's already in transparent mode. So what happens if I say VTP mode transparent? It's going to tell me the mode is already transparent, which is interesting up here because they don't show that it kicks back that output, right? But it's already transparent mode. So we see that VTP domain CCNA. and VTP Password Cisco. But again, the switch is in transparent mode. So what it's saying is, when you say transparent mode, what you're saying is switch 3 is like, okay, I'll go ahead and I'll take your VTP advertisements, and if I've got trunk links that are behind me that go to other switches, I'll pass that information on to those other switches, but I'm not participating in the VTP updating of my VLAN database. That is what transparent mode says. The off mode, and let me, VTP mode, and let's do a question mark. Yeah, so they don't show you the off mode here. At the CCNP level, you need to be aware of that mode. VTP mode, question mark, off. And what that means is I'm not playing with you at all. I am not participating in either the updating of VTP information based off of your VTP updates, and I am not passing that information on. It is off. So let's step back to the activity here, and we've got that all set up. So now we'll say show VTP status, do show VTP status, because we are in global config mode. And we can see that we are in transparent mode and that everything looks good. So now here's what we're going to do. Notice the configuration revision number is 0 on all 3 switches, and explain that. Well, because we haven't made any VLAN configuration changes. So let me show you something here. I'm going to come over to switch 2, which is a client switch, and I'm going to say VLAN 888 and hit enter. VTP VLAN configuration not allowed when the device is in client mode. So I can't make any VTP changes because it's a client mode VTP switch. However, here, do show VTP status, switch number 1 is a server mode. And that's why they're telling us, come here to switch number 1 and type in VLAN 10. So I've just updated and made a change to the VLAN database. We're going to say name red, right? So do show VLAN brief. We now see VLAN 10 red. Create VLANs 20 and 30 according to the same process. So VLAN 20, name blue. VLAN 30, name yellow. Do show VTP, do show VLAN brief. There we go, 10, 20, 30, red, blue, and yellow. So verify that they exist. They do. Which VLANs are configured on switch 1? Well, there's our answer right there. We should now have 10 is what we should see. Do show VTP status. And take a look here. You can see local updater ID. So I just updated the VLAN database. And so we've got VTP updates that should have gone out. You can see 6 changes were made. VLAN number, VLAN name. 10, 20, 30, red, blue, yellow. Those are 6 changes. The configuration revision is now 6. Number of existing VLANs is 10. We've added 3 to the 7 that were already there. Now, this has been done on the VTP server. Everything looks great. So now let's confirm the changes and on switch 1 as well as switch 2. So let me come over to switch 2. We'll do a right mem here and get out to privilege exec because we're not going to be making many changes here from a VLAN database perspective. So let's say show VTP status. Take a look. Configuration last modified. So we had an update take place. The update came in from switch 1. I see 10 VLANs. And you'll notice I didn't configure anything on switch 2 because I can't configure anything from a VLAN perspective on switch 2. And then configuration revision is 6. So we talk about the message, the communications that go back and forth. You've got summary VTP advertisements. Every 300 seconds, there will be a summary advertisement that goes out. If a VLAN was added, moved, changed, and that summary advertisement is going to have the VTP version number. It's going to have the domain information. It's going to have the configuration revision number. That is how switch 2 got all that information. And then you can have a subset advertisement, which is if you have some sort of a VLAN config change and it just needs to be a subset, not the whole VLAN the whole VLAN database being communicated. And then you can have a client request. Now, not subset, I want to say yeah, we'll go subset, right? So subset advertisement, but I want to link the subset in the client request. So we're talking about 3 VTP communications. You've got a summary communication every 300 seconds, every 5 minutes. You've got a subset advertisement that if there's some kind of a change, it could just send a subset of the change, because if you have a client request, which is a new switch gets added and it has a lower revision number, right? So we add a new switch to this topology, and that switch has a lower revision number. It would possibly send a client request saying, hey, I'm seeing VTP messages that have a higher config, because remember, we said in the summary advertisement, the config revision number is in there. What we're saying here is a new client's been added who has a lower revision number. He sees a VTP advertisement that has a higher number. He knows, hey, my VTP VLAN database is out of sync. So he could send a client request saying, hey, here's my revision number and this is what I've got. What do you have? To which a subset advertisement could come back, right? So I want to tie those. The summary, every 300 seconds, every 500 minutes, sends out the VTP version, the domain name information, and the config revision number. A subset is just VLAN configuration change takes place, and you don't need to send the entire VLAN database. You just send a subset. And then a client request. Client comes online. Hey, he sees the VTP revision number from the VTP server, or it could be another client, and says, wow, I'm kind of out of sync here. Client request goes out saying, hey, I need to update. Now, there's another one that's not talked about in the text that exists, and it's a VTP Join. And that's if you're doing pruning, right? And pruning is when you're saying, you know, maybe, and let me give you a scenario here. We have another switch over here, right? And that switch doesn't use VLAN 10 and doesn't use VLAN 20. So on that link right there, we would prune 10 and 20, meaning they don't need to go out here because this switch is all VLAN 30. That's all he needs. And if that's the case, and if we're running VTP, you have your summary advertisement, you have a subset advertisement, you have a client request, you now would also have what's referred to as a join. And the join is sent every 6 seconds. And again, that's only if VTP pruning is active. If we're not doing VTP pruning, which we're not in this environment, you don't have the join advertisement, right? You're not going to see that. But know that that is a possibility, especially when you're pruning VLANs on trunk links where you are running VTP. All right. So we've confirmed the changes with switch 1 and switch 2, and the domains are configured. We see that switch 1 looks just like switch 2. All right, so now let's observe transparent mode. So switch 3 is in transparent mode. Remember, we said what that means is that switch 3 will help us. He'll help us send along VTP advertisements that he is receiving, but do show VLAN brief. He is not going to participate in the VTP domain, meaning he's going to see the advertisements, the VTP advertisements coming from the VTP server switch 1, but he is not going to be making VLAN database changes based on those advertisements because it's transparent mode. And that's what we want. So how many VLANs are configured here? Well, we have the original 7 because those were already configured. It was already in transparent mode. How would you change the number of VLANs on switch 3? Well, I could simply configure new VLANs on switch 3. So let's say VLAN 10. Oh, I didn't want that. We want VLAN 10, and the name was red. And see, I'd have to manually configure these here. VLAN 20, name blue. VLAN 30, name yellow. Do show VTP status. Well, now I do have 10 VLANs, but they were locally configured. Look here. There has been no configuration modification logged by VTP, because while I'm participating in VTP by allowing messages to be sent along and so that other clients or servers can update, I, meaning switch 3 in transparent mode, I am not participating in updating my VLAN database. Do show VLAN brief. And you can see right here, I've got those VLANs, but those were locally configured VLANs. And while we're here, why is gig02 not showing up? Yeah, because gig02 is our trunk port, right? So again, quick segue right there because I saw it was gone and wanted to mention that. Remember, gig02 is a trunk link. It's not going to show in the output of the show VLAN brief. So we've manually configured those. So change the VTP mode to client on switch 3. All right, well, I didn't see that coming up, so let's do this. No VLAN 10, not 109, no VLAN 10, no VLAN 20, no VLAN 30. And then we'll say let me save my config here, show VLAN brief. So now those VLANs are gone, show VTP status. Configuration revision is still 0 because I'm not a client and I'm not a server. I'm a transparent mode switch. Excuse me, and we're back down to 7 VLANs. So now let's come back here, get back in sync with the activity, VTP mode client. So now I'm in client mode, and let's verify things here. So let's say show VLAN brief. Did I get the update? I did, and now I'm playing along, right? Because I'm a client, meaning I want to get VLAN database updates via VTP from the server switch 1. And you can see how much easier this is because now I make my changes in a single location. And those changes are propagated out to all the other switches to which I'm connected via trunk links, right? Remember, it has to be a trunk link for VTP, for VTP to work. And now we've got all of our VLAN database information in sync. So it talks about the VTP advertisements being flooded every 5 minutes. There's that 300 seconds I was talking about, or whenever a change occurs to configurations. And what are they asking me to do here? Okay, so we're going to assign some VLANs to ports. And again, and this is where we have the range command come into play. So on switch 2, and they actually give us the commands that we need here. So that'll make things a little bit easier. So let's get into global config, interface range, fast Ethernet 0, 1 to 8, switch port mode access, switch port access VLAN 10. And what else will we put on here? You notice the orange dot that just showed up? Yeah. We want spanning tree port fast because those are all host-facing ports. What about spanning tree BPDU guard enable? Absolutely. Again, we're not losing any points by doing this. And this would be, again, best practice type thing to do. Spanning tree guard root. All right, so we're good there on switch 2 for those. Interface range, fast Ethernet 0, 9 to 16. Make sure that's right. Yeah. Okay, switch port mode access, switch port access VLAN 20, spanning tree port fast, right? We want that to be on as well. Spanning tree BPDU guard enable, and I'll just leave it there, guard root. So you would do that as well. Interface range, fast Ethernet 0, 17 to 24. Is that right? 17 to 24? It is. Switch port mode access, spanning tree, port fast. And then we'll say switch port access VLAN 30. And then we'll throw spanning tree BPDU guard on there just for good measure. All right, so we've got everything added on there on switch 2. But you can see switch 3. Okay, so they gave us the switch 2 commands. Switch 3, we're going to have to go do some work there as well. And you can see that that is, BPDU guard enable. And you can see that for some reason, fast Ethernet 017, did I not say spanning tree port fast? Okay, there we go. Maybe I got a typo, didn't catch it. I apologize if that was the case. We'll say write mem. So switch 2 is done. Now let's come over to switch 3, where we're going to do much the same thing, except here it's not giving us the command. So interface range, fast Ethernet 01, and it looks like they're exactly the same, and they are. So it would be the exact same commands. Interface range, fast Ethernet 01 to 8, and so we'll just say switch port mode access, spanning tree port fast, and switch port access VLAN 10. And again, we're now at 88%, so I'm assuming that we're going to get 6 percentage points for the rest of this here. So interface range, fast Ethernet 09 to 16. Make sure I get that right. Switch port mode access, switch port access VLAN 20, switch port, spanning tree port fast. So we'll get rid of those ports that are, excuse me, showing as they're negotiating. All right, so that took care of that. And then we've got interface range, fast Ethernet 017 to 24. And we're going to say switch port mode access. And we'll do spanning tree port fast. And we'll say switch port access VLAN 30. All right, and that takes us to 96%, meaning there's something that we missed, and we'll take a peek at that and try to figure out what that might be. Do show VLAN brief. All right, so now the only port that's left out here in the default VLAN, VLAN 1, is gig 01. Everybody else is either in the red, the blue, or the yellow VLAN. And so now it wants us to test traffic here, so we'll go for PC0. And we'll ping PC5. And we're going to have to get some information here. So PC5 is 192.168.10.2. Let's make sure that's right. All right, so PC0 to PC5 works. Now let's ping from PC1 to PC4. And PC4's IP address is ping 192.168.20.2. And that works like a champ. And then finally, I'm assuming it's going to be PC2 to PC3. And we'll say ping 192.168.30.2. All right, and that works beautifully. Now, my question to you, and again, let's talk about this. Can I ping from PC2 over to PC5? 192.168.10.2. Why doesn't that work? Exactly. Because they're in different VLANs. And let me ask you this. Are we doing inter-VLAN routing here of any kind? We're not. So these are not multi-layer switches. These are just layer 2 switches. They cannot serve as routers. And so what we have here is VLAN separation, because nothing on VLAN 10 can talk to something on VLAN 20, and it can't talk to anything on VLAN 30, and vice versa. So all of these VLANs, these broadcast domains, these subnets, are 100% mutually exclusive. They are segregated from each other because we have a pure layer 2 topology here from a switching perspective. Now, what would happen if I was to attach a router out here? Router 1. And that's a trunk port. And I do a bunch of sub-interfaces here for VLANs 30, 20, 10, 99, and the native VLAN, I can't remember, it was 999. Or I think it was 999, whatever the native VLAN was. Then what would happen? Well, all I'd have to do is come to each of these PCs and go to their config and set the default gateway to that value on the sub-interface on the router. And then we would have inter-VLAN routing. Right now, we do not. So nothing in VLAN, in any of the VLANs can talk to anything else in any of the other VLANs because we're not doing inter-VLAN routing. So now let's address this issue, and it's probably here where I messed up. Let's check results, and let's see the dynamic mode for Gig01 on switch 2. I thought we changed that. Let's take a look here. The dynamic mode on switch 2. What did it ask me to do? And maybe I went right by that when we were doing the trunking configuration. And I'm sure it was because I segued off onto some other... Whoops, sorry. Let's get back up here to the DTP. I thought we said switch port mode dynamic desirable, or did I hard code that as a trunk trying to show you guys something? Let's say do show run, come down to gig 01 down here, and no, I just simply left that off. So let's go ahead and say interface gig 01, switch port mode trunk. And I'm sorry, that's what I did that probably caused a problem. Say switch port mode dynamic desirable, and I apologize. I thought that I had done that already earlier on. But that takes us to the 100%. So now let's talk about this, because this is where you sort of go beyond sort of that CCNA, CCNP discussion to say, we talked about this off mode, right? And we talked about transparent mode. So let's come over here and let's go to this activity that I have configured in the dashboard, which is this activity here, where we have 3 switches connected together. Switch 1, switch 2, and switch 3. So let's come to the console for switch 1. And you can see here that we have multiple connections between, and that's why it's so thick here. This link is there's multiple connections between switch 1 and switch 2, because I'm going to be using this to demonstrate Ether channel to you guys here shortly. But what I want to do right now is, let me take a look at the connectivity. And you can see between switch 1 and switch 2, so we'll just use gig 10. We'll use one of the ports. So back onto switch 1 here. Let's come to the console. And let's go into privilege exec, into global config, and let's go ahead and say interface gig 10, switch port, mode, trunk. Right? Oh, and it's auto. So let me go ahead and do this. Let's go ahead and say switch port mode, access, and I did not want that to disappear like that on the bottom. And it is set to auto. So, and now I'm drawing a blank. I need to, it's not no negotiate, or is it no negotiate? Switch port, mode, trunk. Switch port, no, switch port, trunk, encapsulation. There we go. So the encapsulation is set to auto, meaning it could be ISL, it could be .1Q, but again, ISL is not supported. So the mode is set to auto. We don't want that. We want it hard-coded to .1Q. And in fact, let me stretch that command back out and do a question mark. And you can see the Cisco Modeling Labs is showing that ISL is an option. Again, on newer Cisco switches, that is not an option. And so this always throws me when I see the auto, because I forget to come in and say switch port trunk incap .1Q. And again, if I was to come over here and let's do that again, you'll see that I didn't need to say switch port no negotiate, right? So what do we see? I go to privilege exec, global config, interface gigabit 10. And if I was to say switch port mode, say switch port mode trunk, we're going to get the error. What I need to say is switch port trunk incap .1Q. And now that error is not going to show up when I say switch port mode trunk. So that's what you have to do. Again, this CML image that's being used on these layer 2 devices isn't already auto magically configured. And you can already see we've got spanning tree issues, right? Because the encapsulation was inconsistent before I made the change. So here we say switch port trunk encapsulation .1Q, switch port mode trunk. So now we have a trunk link between switch 1 and switch 2. And now let's come over and let's take a look at the connectivity here between switch 2 and switch 3. So I'll open the console, we'll look at the connectivity, and it's gigabit 3.3, right? So this will keep it simple. So we'll come on to switch 2, and we want to do the same thing on switch 2 for internet gigabit Ethernet 3.3. We're going to say switch port mode trunk to see the error, right? It's in auto mode, so I want to say switch port trunk incap .1Q. And these switches are behaving more like, let me say do show version. These are behaving like 3560s more than a 2960. And yeah, it's just whatever this VIO 15.2 image is. And so yeah, for whatever reason, it's those settings are still in there. On 2960s and on newer Cisco switches, that is not something that you would typically see. So we're going to say switch port trunk incap .1Q and then switch port mode trunk. There we go for 3.3. And let's do the same thing over here on switch 3. We're going to go into privilege exec, into global config, into int gig 3.3. And we're going to say switch port trunk incap .1Q. And then we're going to say switch port mode trunk. So I have trunk links, but I have a trunk link between switch 1 and switch 2. And I have a trunk link between switch 2 and switch 3. And here's what I'm going to show you. So on switch number 2, right? So here we are back on switch 2. Let's say do show VTP status. So it's a server, right? Well, I don't want this to be a server, right? I want this to be transparent. So I'm going to say VTP Mode Transparent, right? Now, the domain is null. So let's set and I'm going to leave the domain as null to expand on this conversation of whether or not it will pass along VTP advertisements that have a different domain name. As you can see, the domain name here is null. I'll even say Vtp Password ABC123. And the password has been changed. And then we'll say VTP, and we'll leave the VTP domain as null. So over here, I'm going to make switch 1 my VTP server. So let's go ahead and exit out of interface config mode and say VTP Mode Server. I'm going to say, and again, it's already server because that's the default. We'll say VTP Password. I'll even put a different password. ABCD1234. Right? So there we go with that. I'll say VTP domain is CCNP. So the domain is CCNP. Do show VTP status. And here's our current configuration. And you can see the revision is 0. So let's change that. Let's say VLAN 10, and we'll stick with what we were using earlier, blue. I'm sorry, VLAN 10 blue. Name blue. VLAN 20, name red. VLAN 30, name yellow. Now, remember, this is a transparent mode switch here. So let's get onto the CLI and let's say do show VLAN brief. Okay, everything looks good right now. There's no VLANs configured on switch number 2. So let's change it. I'll say VLAN 777, name lucky, right? So now do show VLAN brief. So I just proved to you that do show interface trunk, we have a trunk link up between these two switches, and you can see that the trunking mode is on and we're trunking, but from a VLAN trunking protocol perspective, do show VTP status, what do we see? I'm in transparent mode. My config revision is 0, even though I've added VLANs, it's still 0. I have a password set. My null is 1, my domain is null, and my revision, the version, I'm sorry, is 1, because by default, you will be running version 1. Okay, so let's say that your boss comes to you and says, hey, connect switch 3 to switch 2, but we want switch 3 to be a VTP client of switch 1. Is this going to work? Well, if what I just told you in the video previously is a transparent mode switch is going to pass that information on, then it should work. But here's what we're going to do first. We're going to prove that the off mode does not pass anything along. So VTP mode off. Meaning switch number 2 is not going to play VTP games. It's not going to forward anything along. It's not going to help you at all. It is off. So now let's come over here to switch 3. And we'll say the previous network engineer set switch 2 to off mode because he never thought that you would add a switch 3 here and that your boss would say, make it use VTP and use switch 1. So here we are on switch number 3. So VTP mode client, right? VTP domain CCNP. And let me double check that really quick to make sure that I set it to CCNP here. Okay, I did. All right. And now let's say do show VLAN brief. Now, if you're thinking, hey, you didn't set the password, this is exactly one of the reasons I'm checking this. So do show VLAN brief. Do we pick anything up? No VLAN 10, no VLAN 20, no VLAN 30. So you might be thinking, Travis, we need the password in there. All right, well, let's put the VTP password in here. So VTP password ABCD1234. And we can even come over here and confirm that. Let's say do show VTP password. It is ABCD1234. I'm over here on switch 3. We'll come back over here. So if the password's the same, the domain is the same, and I'm a client, and I want to participate, I want to play here in the VTP configuration, it is not working. And the reason is because, and this proves that switch 2, when the VTP mode is set to off, switch 2 is not going to help you at all. It is not going to pass along VTP advertisements to any other switches to which it's connected. And so that is why switch 3 is not getting anything. So now let's come in here and let's try to prove that. So the mode is off right now. Do show VTP status. You see the mode is off right here, right? So now let's go ahead and say VTP Mode Transparent. So I change it to transparent mode. And remember what I told you earlier is that if the switch is in transparent mode, it's not going to update its VLAN database with VTP advertisement information, but it will be your friend and pass that information along to any other switches to which it might be connected over a trunk link, and that then that switch, and here's our moment of truth, would update its VLAN database because it wants to participate in that VTP routing domain. And what are we seeing? We're seeing that it's not. And so there's still one more thing we need to do here. Remember on switch 2, we never set the domain up because there's been an argument, and this goes back a while, that the domain name has to match on the transparent mode server. Now, it doesn't need to be participating from an update perspective, meaning updating its VLAN database, but there's certain scenarios where, and this is one, where maybe the domain name needs to match. So what if I say VTP domain CCNP? So now we have updates coming in, and it could also be that I didn't wait long enough, right? Remember, switch 1 and switch 3, in fact, let me change that on switch 2. Hopefully it didn't switch out there. Let's see. And it picked it up. So it got VLAN 10 and VLAN 20, but it hasn't gotten, I thought we created VLAN 30. Let's double check here. So it could be do show VLAN brief. Let me show VLAN brief. I thought we had 30 in there. Okay, now we do, because we had, again, this iOS image that I'm using, right, that is part of CML here, is showing some older iOS behavior where you need to exit out of the VLAN database for that last VLAN that we added in there to show up. And so now let's check over here and see, do I see 10, 20, and 30? And now we see 10, 20, and 30. But it could have been that I just wasn't patient enough. So let's go back to switch 2, and let's say VTP domain ABC. So now the domain has changed. So now I'm going to come to switch 1. Remember, we talked about the summary advertisements, the subset advertisements. So now I'm going to do something that's going to force an immediate advertisement to take place. I'm going to say VLAN 40, name purple, P-U-R-P-L-E. And then we're going to say VLAN 50, name, I'm out of colors here, black. Let's use black. And then I'm going to say end, right? So show VTP status. And take a look here. DTP domain mismatch, unable to perform trunk negotiation because we have, and that's okay because we don't want it to negotiate. But the command that I didn't put on those ports, I don't believe, show run int gig11. Did I not say? I thought we said show run. Am I using 1.1? What's the link I'm using? Well, let me do this. Show interface trunk. Oh, gig 10. Sorry. Show run interface gigabit Ethernet 10. Because I want to see here. Yeah, I did say no negotiate. But you'll notice that we get this message here on this image saying it's unable to perform trunk negotiation because of a VTP domain mismatch, right? Because we changed the VTP domain here, but we don't want trunk negotiation. We're not interested in DTP because we have disabled DTP, but it's showing all of those other ports, right? You'll notice that, because again, there are multiple ports connected here between these two switches. Do you see 10, which is the port we're using? Is it listed here? It's not, because there is no issue on that port because we are not using dynamic trunking protocol. We said switch port no negotiate. And so just ignore these. These are all these other ports that are connected between the switches, but not set up to do trunking, which is what we're doing here. So I changed show VLAN brief. So let's go back to this. I changed the VLAN database. I've updated it. I added the purple VLAN and the black VLAN. VLAN's 40 and 50. Let's come to switch number 2. Is switch number 2 do show VLAN brief? Is he picking up any of that VLAN information at all? No, because he was in off mode, then he was in transparent mode with the same VTP domain. So you saw, even in transparent mode with the same VTP domain, it is not updating its VLAN database based on those VTP advertisements. Now we come over to switch 3, and this is really the moment of truth here, is switch 2, as we've seen, has a different VTP domain name configured. So with a different VTP domain name in transparent mode, will it pass on the VTP summary advertisements? In other words, will it share with switch 3 that there has been an update? And you can see here that that is not what is happening. Now, to be clear, this is the behavior of this iOS version, this virtual version that's being used here. On real Cisco switches, I have seen where the domain name does not have to match on the transparent mode switch to allow it to pass the information on. But let's change the name to CCNP so that it matches. Then we'll come back to switch 3 and we'll say do show VLAN brief, and we should see here, we'll give it, again, remember, we've got advertisements that could be going out here. We might need to be patient, but let's force a change on switch 1, and we'll say VLAN, I can't remember where we left off, we'll say VLAN 90, name, we'll just name it prod for the production zone. Now, look here, if I say do show VLAN brief, this is sort of legacy switch behavior where it doesn't show up in the VLAN database right away. I have to get out of the VLAN database, then say show VLAN brief, then the VLAN shows up. Let's come way down over here and let's see. Do show VLAN brief. Did I pick up black and purple and prod? And there it is. So with this version of iOS on these switches in this virtual environment, the VTP domain name had to match. That is not always the case. And again, small subtleties here that I want to make sure I covered. But when the switch is in off mode, rest assured that in off mode, it's not passing anything along. And it is not participating in any form or fashion. And again, that's why there's the difference between the transparent mode and the off mode. All right, well, I think I've gone on long enough here about the dynamic trunking protocol and the VLAN trunking protocol, both proprietary from Cisco. And actually, the last thing I wanted to show you is here is the United States patent. I think I said trademark. I think a patent implies trademark. And what is it for? The dynamic trunking protocol. Here are the creators of that. If you'd like to thank them for giving you the option for dynamic desirable, dynamic auto, the on mode, right? And there's a quick abstract, and then it goes into all kinds of details that are sort of at the nosebleed level with respect to ISL functional specifications. You've got all kinds of information here. A great document. If you Google this and just Google the patent number here, US 6445715B1, you will find this publicly available. Great document to have for posterity, and again, for historical reasons, so that you can understand some of the legacy things that happened in the Cisco environment. All right. Well, thank you guys so much for watching. I hope this has really expanded your understanding of the VLAN trunking protocol, versions 1, 2, and 3, some of the limitations that are involved, and DTP, the dynamic trunking protocol, which allows Cisco switches to be plug and play if you would like. And again, Cisco best practice, hard-coded as a trunk if it's going to be a trunk. Disable DTP if it doesn't need to be running DTP if you've hard-coded it as a trunk. All right. Thanks you guys so much for watching, and I hope to see you in the next video.